Alright, hello. We'll jump into this right away. We're using Gaussian elimination or row echelon form, final row echelon form to solve these systems. If it's a one solution, we want our final answer as a coordinate. If it's infinite, then we want to substitute a in for z and then back substitute and get x and y in terms of z as well. So I have my system written in augmented matrix form. First we want to get this is a 0, then this is a 0, then this is a 0. Through that process, hopefully we get a 1 here. If not, then we need to do what we need to do to get this a 1 as well. So starting off with this being a 0, we want to do negative r1 plus r2. I'm going to write that over here. And that will give us a new r2. We also need to get rid of this, so we're going to multiply this by a negative 2, which would give us negative 4, and then add it to that, which would give that a 0, so negative 2r1 plus r3. This is a new r3. So I have the first row written already, as we're doing nothing to that, so negative r1 plus r2. So even though this goes to 0, I still take the time to make sure that it does give me 0 truly. Negative 2 plus 2 gives us 0. Negative 3 plus negative 3 gives us negative 6. Negative 1 plus 3 gives us negative 4, and then negative 10 plus 22 gives us positive 12. We'll multiply the top by negative 2, so we have negative 4 plus 4 gives us 0. Negative 6 plus negative 2 gives us negative 8. Negative 2 plus 3 gives us 1. Negative 20 plus negative 2 gives us negative 22. So we also, I didn't mention before, we need to make this a 1. So I'm going to make this a 1, I'm going to make this a 1, and I am also going to eliminate this negative 8. So to first make this a 1, we have to multiply this top by a half. I'm going to go a half times r1 gives us a new r1. I'm going to go negative 1/6 times r2 gives us a new r2. I'm going to look to eliminate these two. Our LCM is 24. So I'm going to multiply the second line by negative 4. So negative 4r2 plus 3r3 gives us a new r3. Now we have to do it by a negative, so they're opposites of each other. So writing out the next line. Half of the first, so 1, 3 over 2, 1/2, and then 10 divided by 2 would give us 5, 0, negative 1/6, that would give us a 1 there. Negative 1/6 times negative 4th would be positive 2/3, and then 12 times negative 6 is negative 2. Now in this last line, first off we have a 0 here. Remember, these calculations are talking about the current rows, not the future ones. So this negative 4 is being multiplied by this, and the 3 is being multiplied by that, so that would be positive 24 plus negative 24 gives us a 0. Negative 4 times negative 4 is 16, plus 3 is 19. Negative 4 times that is negative 48, plus negative 66 gives us negative 114. And 19 goes into 114 evenly. So if we do 1/19 times R3, it gives us our new R3. And I'm totally cool with you just doing those calculations here rather than writing everything out again. And that will give us z equal to -6, so we put a 1 and a -6 there. And now we have z equals -6, and now we're going to back substitute. So we have y plus 2/3 times -6 equals -2, y minus 4 equals -2, which now gives us y equal to 2, and then we back substitute for x. Excuse me, x plus 3/2 y equals 2 plus 1/2 z, which was -6, equals 5. So we have x plus 3 minus 3 equals 5, so we get x equal to 5, and that gives us our coordinate 5, 2, -6. So now coming to problem B. In this first step, we want to make that a 1, eliminate that, and eliminate that. So I'm going to use this 2 to eliminate that. We're going to multiply this by -1 and add it to that, and same with this one. So when I write that out, I have -R1 plus R2 gives us a new R2, and then -R1 plus R3 gives us a new R3. And note, these are using the R1s from the current one. At the same time, I want to multiply the top R equation by positive a half to get that to be a +1. But again, remember, we're still using the current 2x, the coefficient of 2, to eliminate these. So we're talking about this half here. Let me write this out properly, R1. That's going to talk about the future R1. So when we do that, we are first dividing all these by a half. That gives us 1, a half, 1, and then half of 4 would be 2. And now I'm going to do my row operations right here. -2 plus 2 gives us 0. -1 plus 2 gives us 1. -2 plus 0 gives us -2. -4 plus 5 gives us 1. Next, we are going to do -1 plus R3, so -1 plus that would give us, R3 will give us 0. -y plus -y gives us -2. -2 plus 6 gives us 4. And then -4 plus 2 gives us -2. Now we're going to work on eliminating this, so I'm going to multiply this by 2 and add it to that. That would be -2R2 plus R3, new R3. Come down here. We have 1, 1/2, 1, 2, 0, 1, -2, and 1. And then we have a 0 here, and now we do our row operations. -2, oh, whoops, that should have been a +2. My bad on that, so it should be a +2. Multiply this by +2 just to check it. +2 times that would be 2, plus a -2 will give us 0. Want that in black. Two times this will give us -4 plus 4 is 0. 2 times this would be 2 plus -2 is 0. So when we get 0 in the bottom row, that gives us an infinite solution. Therefore, we have z equal to a, and now we back substitute that a into the z term here. So we have y minus 2a equals 1. Y minus 2a equals 1. If we add over the 2a, y equals 2a plus 1. And now we're going to back substitute into our top line here. So we have x plus 1/2 times 2a plus 1 plus a, as a goes in for z. And then we have the constant of 2. Solve this for x, distribute x plus a plus a half plus a equals 2. So we add the a's together over here, gives us 2a. We move it over to the other side, gives us negative 2a. And then we have a half move over, so we have 2 minus a half will give us 1.5 or 3 halves. So our solution is x, negative 2a plus 3 halves, comma, y, which is 2a plus 1, comma, z, which is a, and that is our infinite solutions, or all of the points on a line where the 3 planes intersect. If I picked a value for a, we would then get a value for x, a value for y, and a value for z. That would mean that point is on that line for that a value. And then you could pick another a value. You could do that infinite amount of times and you have all of the solutions. Coming over to this one, what I'm going to do is I like that row 2 has a 1x coefficient of 1. So first thing I'm going to do is interchange my rows. Row 1 and row 2 I'm going to interchange. And this could kind of get a little confusing. So what I'm going to do is just that and then go for my row operations from there. So now that I flip those 2 rows, I can do my operations. I'm going to multiply this by negative 2 and add it to that. So I have 2r1 plus r2 gives us a new r2. Negative 3 times that. Negative 3 times r1 plus r3 gives us a new r3. Rewrite the first. So now I'm going to combine these. I'm doing this operation right here. So negative 2 plus 2 gives us 0. Negative 2 times 2 is negative 4 plus 5 is 1. Negative 2 times 6 is negative 12 plus 15 is 3. Negative 2 plus 4 is 2. And then we do the same thing for same operation idea, except obviously with this operation. So negative 3 times this plus that will give us 0. Negative 3 times that is negative 6 plus 1 is negative 5. Negative 3 times this is negative 18 plus 3 is negative 15. And then negative 3 times 1 is negative 3 plus negative 6 is negative 9. Now our goal is to eliminate this, so I'm going to multiply this by 5 and add it to that. So that would be 5, oops, I'm going to do it down here, 5 times r2 plus r3 gives us a new r3. To do that, we do 0 and 0 will give us 0. 5 times r2 plus r3, so 5 times this plus that is 0. 5 times that is 15 plus negative 15 is 0. 5 times that is 10. 10 plus negative 9 is 1. So down here this means we get 0 equal to 1. That is a no solution. Just like in an equation. Just to give a quick example, let's say I have an equation 2x plus 4 equals 2x plus 6. There's not a solution to that. If I eliminate the x's, you have 4 equal to 6. Same idea here. 0 equal to 1 gives us no solution. Here you're just trying to find values for those boxes that would solve the equation, or to find a value for that would satisfy the equation. And just for nice neat, I'm just going to write the solution up here so we know the solution of the system is this. So we're just going to plug those in for x, y, z and then solve for the blank. So I'm going to rewrite it below. So I have 2 times 2, right? So I have 2x, but x equals 2, so I plug that in, minus y, which equals 3, plus, I'm just going to keep this as an open box. Of course, we could make it a variable, like a or b, whatever. I'm just going to keep it as that open box, and then I have z equals negative 1 equals negative 8, and then I'm just going to solve that. So let's hopefully be able to do this in our heads. We have 4 minus 3. This is a positive 1. I move the 1 over, so I have negative 8 minus 1 is negative 9. And then if I divide by a negative 1, that would be a positive 9. And then we're going to repeat that process for the next two. So I have a box. I'm again plugging in 2 in for x, minus 3 times y, which is 3, plus 4 times z, which is -1, equals -15. So if I combine, this is -9, this is -4, so -9 minus 4 is -13. Add over, you have +13 added over, so I have a -2. So I have a -2 over here. Divide by 2 will give us a -1 for our solution for that box. And we do the same for the last equation. So we have 5x, x is 2, so I'm going to plug x in, plus there's our box, y is 3 minus z, which is -1, equals 17. And I go ahead and solve for the box, just like if I was solving for a variable. I have a 10 here, plus a 1 is 11. Subtract the 11 to the other side. 17 minus 11 is 6, and then 6 divided by 3 would give us 2. So that would be filling in the boxes there. Alright, so solving a system using A inverse B. So first, if I wrote out this in matrix form, so I write my coefficient matrix. -5, there we go, sorry, it's kind of an ugly 5. And then this is our x, y, z matrix. I'm going to explain this after I write this out. -4, 1, -3. This is the matrix form. Now we're used to writing this in augmented form, but you could also, this is non-augmented, this is the actual multiplication of this 3 by 3 times a 3 by 1 to get this, which represents this equation right here in matrix multiplication form. If I go this row times this, that'd be 2x plus -2y minus 6z equals -4. That's literally the equation there. And if I did the same, we would get that second equation. If I did this, I would get the third equation. So just a quick recap, I have ax equals b. This is a right here. This is a times x equals b. So what if I wanted to solve for x here? But we have to keep in mind that these are matrices. So when we do matrices, we have to multiply by the inverse matrix. And if I take A inverse times A, that gives us the identity matrix. Identity times x is just x. So this is the matrix way of solving for x. And since order matters in terms of multiplication, if A inverse is out front, we need it out front as well. And that's why we get to this equation of x equals A inverse B. So how do we find the inverse of this? Well, in this problem, we can do it using our calculator. You'd plug this in, I'll just describe it. Plug this into your 3 by 3 into your matrix in your calculator, and then you're going to go to your home screen, you're going to type in A, the A matrix, by using your matrix function on your calculator, and then you're going to use the x inverse button after A, and then you're going to plug this into your B matrix, and then in that home screen you literally are going to have this typed in. See, like I said, you have that A inverse, and then you put B right next to it, and then it will give your solution. So if you did it separately, your A inverse matrix is equal to, because if you just did A inverse by itself, it would give you that matrix, and you would get -1, -1, 0, -2.25, -1, 1.5, 0.25, 0, and -0.5. If that's not what you got, I'd suggest that you check your solutions as you plug those in to make sure. Just want to make sure that's right. I have that, yeah. So if I do that and I multiply it by b, we end up getting x equals, your calculator will give it to you like this. It will look like this, 3 times 3.5 and 0.5. And as a coordinate, that would be 3, 3.5, comma 5. Sorry, not 5, that's a 0.5, so this would be a half. And this would be 7/2. Me personally would not take off if you had it in decimal form. It's kind of nice having fraction form there. Okay, So coming down, now we're just doing some basic operations with matrices. For A, we're doing 2B minus 3C. First, I want to take a second, evaluate, looking at A, B, C, D, and E, and seeing what we have here. So A, we have a 2 by 2 matrix. B, we have a 2 by 3 matrix. C, we have a 2 by 2 matrix. But look at those bars. Very, very important to look at those bars. Those look like those absolute value bars, which means the determinant. So C is not a matrix. It is a determinant of matrix, which is a number. D is a 1 by 2, and E is a 2 by 3. So if we look here, we have 2 times B. I would make 2, and I multiply it by all of this. And I subtract 3C from it. Well, if I have a matrix, a 2 by 3 matrix, and I want to subtract a number from it, that's not an operation. That's possible. So we're going to write not possible for this one. For BE, we want to see if it's possible to multiply these. Well, the size of B, so if I go B times E, B first is a 2 by 3. I'm going to see if it's possible, times E, which is a 2 by 3 as well. These numbers have to match up in order to multiply the matrices, so this is also not possible. Let's check out C times A. C is a determinant, which would be a number, so I'm just going to put this a number. And then A is a 2 by 2. Is it possible to multiply a number, which in matrix, or matrix lingo we say a scalar, is it possible to multiply a number by a matrix? Absolutely, that we multiply it in by all terms. So let's go and write that out. So I have 2 times matrix A. Oh, oops, I'm sorry. We want to get the determinant of C. So we can go ahead and calculate that. I'll do it up here. Be 4 times negative 1 minus 5 times 7. Right, we go that one times that one, AD minus that one times that one, BC. So AD minus BC, negative 4 minus 35 is negative 39. So down here, negative 39 is the determinant, which is negative 39. So I have negative 39 times A, which is negative 3, 0, 5, and negative 9. So we're going to multiply that nice, being sarcastic here, that nice number of negative 39 times all of those. And I could definitely do these calculations in my head, but I'm going to use a calculator just to make sure that I don't make a silly, fallible mistake when I do these multiplication. So I do negative 39 times negative 3 gives us 117. Negative 39 times 0 gives us 0. Then I go negative 39 times 5 is negative 195. And then lastly, 39 times 9 is 351, and it would be positive. So we have 351. Next we have C times, oh, we did C times A, sorry. So next D, we did D times A. D, I'm just going to write the order here. So D is a 1 by 2 times A, which is a 2 by 2. So we can do this, the 2's match up, and then the outside will give us the size, which is a 1 by 2. So I'm going to write a 1 by 2 here. So we go D, row 1, times column 1, and that will give us entry 1, 1 right here. So negative 5 times negative 3 is 15, plus 2 times 5 is 10, so 15 plus 10 is 25. And now we are going to do row 1 times column 2. Negative 5 times 0 is 0, plus 2 times negative 9 is negative 18. That was row 1 times column 2. So this is entry 1, 2. That is your answer for DA. Next we have FD. F is, I'm just going to say this verbally, F is a 2 by 1 times D, which is a 1 by 2. So a 2 by 1 times a 1 by 2 gives us a 2 by 2. So for F, row 1 times column 1, it's just 3 times negative 5 is negative 15. Then we are doing row 1 times column 2, and that's just 3 times 2 is 6. And then we have row 2 times row 2, times column 1 would be entry 2, 1. Negative 5 times 1 is negative 5. And then row 2 times column 2 is 1 times 2 is 2. And there's our FD. CD is going to be C, which is negative 39 times the matrix D. That is going to give us 39 times 5 is 195, and 39 times 2 is negative 78. Last one is E times B. We'll go ahead and write this out. E is a 2 by 3. B is a 2 by 3, and therefore that is not possible as well. Okay, so on the test you will have a 3 by 3 where you have to augment it and do your row operations. So we're gonna practice this twice doing this. So just to save time and space, I'm gonna make like our augmented right here with the dotted lines going down the middle, and make that a little like that. Think about that as our dotted line. Okay, so we need to make this our identity. So first I'm gonna multiply this by negative 1/2 R1 to give us a new R1. And I'm also going to use what I have here to make that a 0. So that would be 3 times R1 plus R2 to give us a new R2. So if I multiply the top by negative 1/2, I get 1. I get negative 5 over 2. I get, here's our dotted line, negative 1/2, and then 0. And multiply this by 3 and add down gives us 0. Multiply this by 3 is 15, plus 4 is 19, and then we do 3 times this plus 0 is 3, 3 times 0 is 0, plus 1 is 1, and divide this by 1/19 to make this 1. So 1/19 times R2 gives the new R2. And rewrite the top, negative 5 over 2, negative 1/2, 0, and I have 0, I have 1, I have 3/19 and 1/19. Now we're going to work up, we're going to use this to make that a 0. So I'm going to multiply the bottom by 5 over 2, R2 plus R1, that would eliminate that, it gives us a new R1. Do that, we have 1, we have 0, 5 over 2 times this would be 15 over 38 plus negative 1/2. Ooh, some nice fractions here. Remember, all of this is calculator, so if you want to do the fraction calculations in your calculator, that's totally fine. So it gives us negative 2/19. Next we're going to do 5 over 2 times 1/19 and then plus 0. So that would be 5 over 38. And down here we have 0, 1, 3/19, 1/19, and right there is your inverse matrix. Okay, for B, I am going to make that a 1 in the upper corner first. Let's go ahead and make this augmented. Of course, we got that dotted line down the middle. I want to get that 4 to a 1, so I'm going to 1/4 R1, because it's a new R1. And I'm going to go R1 plus 2 times R2 to make that a 0. It's going to give us a new R2. Sorry, sloppiness there. There's going to be a 0 there. Okay, so if I multiply the top by 1/4, that will give us 1. That will give us 3, 1/4, and 1/4 times 0 is 0. And then if I do R1 plus 2 times that, that would give us a 0. Let's see, R1 plus twice that would also give us a 0. And then if we did R1 plus double that, that would give us a 1. And then if we did R1 plus 2 times that would give us a 2. You don't have a 1 here, so it is impossible to find the inverse, therefore no inverse exists. This matrix does not have an inverse function, or an inverse matrix, excuse me. Okay, trying now the same method with a 3 by 3. So I'm first going to augment this. Me personally, I'm cool with you doing this on the test just to save yourself some time. Let's see here. I am going to interchange R1 and R3 so I can get this 1 up here. So I'm going to go R1 and R3 interchange. At the same time, I want to think of this is now going to be down here, and I want that to be a 0. So I'm going to add these as well, and then insert that, and go R1 plus R3, and that is giving us a new R3. So this right here indicates that we are flipping these two. We could write that right away, but that's a lot of work to write all that out just for a simple flippage, so I want to do this at the same time. I'm going to add these together. Remember, this is getting flipped down here, so when I add them, I get a 0 here, and it's going to be on my bottom line. I also am going to use, actually let's use this one. I mean, we could use this one as well, but I like the fact this is negative already. So I'm going to go 3 times my current R1 plus my R2, and that's going to give us a new R2. Okay, so let's give this a shot. Dotted line down the middle. I'm going to first flip this to here. So that's just a flippage of this up to the first row. Now I'm going to add this to this, and that's going to go in my third row. So 1 plus negative 1 is 0. 4 plus negative 2 is 2. 7 plus negative 2 is 5. 0 plus 1 is 1. 0 plus 0 and 1 plus 0 gives us a 0 and a 1. Now remember, this R1, when we're going to figure out what our second row is here, this R1 is talking about our current R1 up here. So I'm going 3 times this row plus that row. So negative 3 plus 3 is 0. Negative 6, remember we're multiplying by 3. I'm not going to say that out loud. I'm just going to say what it is. Negative 6 plus 7 is 1. Negative 6 plus 9 is 3. 3 plus 0 is 3. 0 plus 1 is 1, and 0 plus 0 is 0, so we have a 1 and a 0 there. Now we need to get rid of this 2, make it a 0, so I'm going to multiply this by negative 2 and add it to that. So we have negative 2R2 plus R3 gives us a new R3. And the first one is going to be a 0, and then I have, again, I'm just going to say what the result is when I multiply by negative 2. So I have negative 2 plus 2 is 0. Negative 6 plus 5 is negative 1. Negative 6 plus 1 is negative 5. Negative 2 plus 0 is negative 2. 0 plus 1 is 1. Now we want this to be a 1, so I am just going to write it and change. You go negative R3 and multiply R3 by negative 1, and that's going to give us our new R3. And I am just deciding I'm going to erase these negatives. So again, negative, and my suggestion to you would be maybe just canceling them out, like keeping them as like positives. You take the negatives and turn them positive just to indicate, like, if you make a mistake and you got to go back, you can easily see that, instead of just erasing them like I did, and I'm just erasing them in the interest of time. And then of course I'm talking about it, so that's not bringing down the time. Anyways, let's make this now. Once we have these zeros and one's going to cross, now our next step is to make that a 0, make that a 0, and then that a 0. We can make these zeros at the same time because they're different row operations. So to make that 0, I'm going to, for both of these zeros, I'm going to use this one down here. So I'm going to go negative 3R3 plus R2 to give us a new R2. And then I have to multiply the bottom by negative 7R3 plus R1 to give us a new R1. So when I do this, bottom row doesn't change at all. How about I just write that in? Since I don't even have to think about it, I just write it. Now I'll go ahead and do this row. I know this is a 0, this is a 1. Since these are zeros down here, it doesn't affect those terms. I'm going to go negative 3 plus 3 is 0. negative 15. Negative 15 plus 3 is negative 12. Negative 6 plus 1 is negative 5. And then positive 3 plus 0 is 3. Next I'm going to do the top line, which is going to be negative 7 times R3. So first off, the 1, 4 don't change. This is going to change to a 0. Negative 30, so again, negative 7 multiplied these is what I'm going to say out loud. So negative 35 plus 0 is negative 35. Negative 14 plus 0 is negative 14. Positive 7 plus 1 is 8. Lastly, we need to get rid of this 4 here. So to get rid of the 4, we got to use the second row. So we're going to go negative 4R2 plus R1 gives us a new R1. And zoom out. Do the work over here. So we have 1, 0, and then here we have 0 plus 0 is 0. I'll go ahead and fill in this side. We now have our identity matrix over here. This is a 0 here, and a 1. Sorry for the scribbling. And now we go negative 4 times this is positive 48, plus negative 35 is 13. 20. Again, remember it's multiplied by negative 4. 20 minus 14 is 6. Negative 12 plus 8 is negative 4. And I rewrite the rest of it. Negative 12, negative 5, 3, 5, 2, negative 1. There is our inverse matrix. The determinant of a square matrix is AD minus BC. And it's set equal to 0, so we simply just go through the motions and solve it. So this times this would be 2 minus x times, now I'm going to get a little creative here, not overly creative, but I'm going to factor out this negative 1. So think about if I have negative 8 minus x, I factor out the negative 1. Since this is all multiplication of numbers, I can take this negative 1 and move it out front, and move that negative 1 out front. And since I factored out that negative, I have 8 plus x there, minus, that's your AD, minus BC, which is 5 times 3, which is this 15. And now we go ahead and solve this. So opposite of, we're just distributing 2 times 8, 16, plus 2x minus 8x. So let's just combine those middle terms. So I have a 2x and a negative 8x would give us minus 6x. And then negative x plus x would give us negative x squared minus 15. And if you haven't noticed already, this is simply going to be a quadratic. So I distribute the negative in to all terms. That will give us a positive x squared. I'm going to write in standard form. Positive 6x minus 16 then gives us a negative 31 equals 0. That is not factorable, so we can either complete the square or you can use quadratic formula. Quadratic formula I think is fairly straightforward. I'm going to show you completing the square in the context of solving a quadratic. We have x squared plus 6x plus blank to get our perfect squared. I move over the 31, and whatever I'm adding to the left-hand side, I'm also adding to the right-hand side. I take this, divide it by 2 and square it. That divided by 2 is 3. 3 squared is 9. So I'm putting a 9 here, and I'm also putting a 9 there. And that would give us x plus 3 squared equals 40. Square root both sides, so I have x plus 3 equals plus or minus root 40. Root 40 breaks down into 4 and 10. Square root of 4 is 2, so I have a 2 root 10. And then I subtract over the negative 3. I subtract over the 3, so I have negative 3 plus or minus 2 root 10. There is your solution. For the next part, we're calculating the determinant. So I want to look for rows or columns that have zeros. Well, luckily, we already have rows. Row 1 has 2 zeros. So when you do this, the only term that's going to contribute is this term right here, because the 0 times, cancel this out, the determinant of the that minor, which is equal to cofactor in this case. Since that's 0 times whatever, you don't even have to write it. But if you did, it would look like this, 0, and then you'd have, cancel out this and this, it'd be 0 times 2 minus 4 times 3 will go in here, but it doesn't matter because that's a 0. So I'm not going to go through that. So I'll just write out, because we'll have other ones where we don't have all zeros. So the only contributing term here is right here. And remember, it's the entry times the cofactor. Well, this is row 1, column 2. And when the row and column add to be odd, the cofactor is equal to the opposite of the minor. So you got to put a negative out front, a -4 times the determinant of what's left over. So if I cancel out that row and column, I have 6 times 2, which is 12, minus 3 times -1 is -3, which gives us a +3. So that'd be 15 times -4. Determinant would be -60. So how about we try row 2 here? So important to know our cofactors and minors. Remember, this is a plus, that's a minus, this is a plus. This would be a minus, that would be a plus, and that would be a minus. And then our bottom row, which isn't relevant for this problem, but just for good measure, that's a plus, minus, plus. So if I decide to use this row, the opposite of -6 is I'm going to put the equal sign here. Opposite of -6 is +6. And if I cross off this row and this column, the leftover 2 by 2 is that 4 times 4 is 16 minus 3 times 1. And then next, I'll go ahead and get rid of that. And then put in my pluses back in there. So this is a minus, plus, minus. So this next part is a plus. It doesn't matter because it's a 0. And now I have, since I have the 0 here, I don't even have to do that one. I'm going to work on this one, which is a -2. Minus comes from the cofactor, which is indicated in that symbol. And if I cancel those out, cancel out the row and column of the 2, we're left with this 2 by 2, -2, 4, 5, 3. So I have AD, which is -2 times 3 is -6, minus 4 times 5 is 20. So if I simplify all that, I get 13 times 6. So we have a 78. Minus, it'd be -26 times 2, which should be 52. And then add those together, we get a determinant of 130. Come over here, we're doing the exact same thing, and I'm just going to go row 1 here. It's just going to have variables in it, so it's going to give us some expression. We're just going to simplify the expression as best as possible. So we have 4, and then these cancel, so here's our matrix. -3 times -1 is 3, minus 1 times 4 is 4. Next term is minus the 7 because the cofactor being negative, so I have 7 there. And cancel those out. I have p times -1 is -p. And these are canceled, so I have p times -1 minus -20 would be a plus 20. And then our last term would be plus -1. Could have just written a minus 1. I'm just going to put plus -1. Same thing. These cancel. P times 1 is p minus positive 15. So p minus 15. And now we're just going to simplify this. So we have a -1 times 4 gives us a -4 plus distribute the -7p, so I have a 7p minus 140 minus p plus 15 when I distribute this negative in right here. And I'm just going to combine like terms. So 7p minus p gives us 6p, cross those out. And what do we get? -125, -129. So for this one, we're using Cramer's rule. So if I want to solve for a, it's going to be a determinant divided by a determinant. Remember, the denominator is always going to be the coefficient matrix, which is right here. So we'll go ahead and do that first since that's the nice easy one. 5, -2, 1. 3, -3, -1. 2, -1, -7. And then if we're solving for a, in the numerator, we take the constant column and insert that for the column of A, which is the first column. So 15, -7, -3. Again, that's taking this and inserting it into our first column right here. And then the rest of the matrix is written the same. -3, -b, 1, -1, -7. I put -b there. Okay. -1. There we go. And then we just plug those matrices in the calculator and get out our answer. I will make another video, as I've indicated in class, about some calculator work. If you calculated those determinants and then divided them, you would get A equal to 6. For B, same thing. You have this matrix right here, down here. I'm not going to write it in the interest of time for yourself and me. Again, if we're solving for B, we're going to take the constant column and insert it into the column for the coefficients of B, and the rest is going to stay the same. So our first column, 5, 3, 2 is the same. But now we're going to take this and insert it for B, which would be 15, -7, -3, and then C would be 1, -1, -7. And if we do that calculation, we end up getting 8 for B. C equals, again, you have your coefficient matrix there. For the numerator, you are going to take the 5, -7, and 3 and put it in the last column. So here we have 5, 3, 2. Last column is going to be 15, -7, -3. And the B column is -2, -3, -1. -2, -3. Is it negative or positive 1? -1, yep. And again, you can plug those in your calculator and you end up getting 1. So that gives us the solution of 6, 8, 1. Area of a triangle is a fairly straightforward formula. It's plus or minus 1/2. And then you have x1, y1, 1, x2, y2, 1. Whoops, y2. And then x1, x3, y3, y3. I'm going to get it right one of these days, and a 1 there. So you're just inserting these points into these and then calculating this determinant, multiplying it by the plus or the minus 1/2, depending on what this number ends up being. If it's positive, you multiply it by positive. If it's a negative, you multiply it by negative because you want a positive area ultimately. So let's see what happens here. So plus or minus 1/2. First coordinate, and again, it doesn't matter the order in which you insert these. You can insert them in any order and the calculation works out all the same. 1, -4, 1. And if we calculate that, you could do that by hand, or you can use your calculator using the determinant function. You end up getting -20, which ends up giving you 10 units squared when you multiply -20 by the -1/2 to make it a positive area.